Okay. We have a binomial, trinomial. Let me just start again. Okay, in the binomial and the trinomial, we can recognize a certain pattern that we discussed the other day, right? The first term of the binomial, if we square that, that will give us the first term of the trinomial, right? If we square the last term of the binomial, that will give us the last term of the trinomial. And then we need to check for the middle term. If we multiply these two terms together, that will give us negative 2x, right? Do we notice that the middle term here has 2x, but just with the opposite sign, right? If that happens, then remember we're going to do x times x squared. That's going to give us x cubed. For the last term, we're going to do negative 2 times positive 4. That's going to give us negative 8. And then all the in-between terms, because this is negative and that one is positive, all of those are going to cancel out. All right, so if we are getting two brackets like that, we end up with, because there's a minus in the binomial, a difference of 2, 3. Okay, I'll just show you that note again quickly. This is what we did on Monday, right? Where we actually multiplied them out the long way, and when we simplified, we saw that we can recognize that pattern. Okay, then we use that in the last question, where we had to group those two brackets and those two brackets together so that we could just make our actual multiplying a bit less. Okay, so see if we can keep on identifying those patterns. I know it does get a bit overwhelming when there are so many patterns to look after. Okay, but we did summarize all of them in core. So maybe that's a good idea to have that summary in your AP book as well, possibly. All right, or maybe take a picture of that summary so that you can work with it when you're doing these questions. But guys, in core, these questions don't usually get this complicated. All right, in AP, obviously they can. So when you do that multiplication, you get this bracket, x cubed minus 8. And now as we're looking at these two, we notice that it's the same bracket. So I just put in an extra step. You don't have to do this, but I just wrote that this, the bracket multiplied by itself is actually the same as the bracket squared. And then I applied the squaring binomial shortcut. Or you could have just followed out and simplified, that's fine. Okay, so that is what I tried to do in all of these questions. I tried to recognize the pattern and then apply those patterns. Do we see that we have the same exact product in the first two brackets here in the next question again? Right? So that again is x cubed minus 8. But now the second bracket is x cubed plus 8. Now guys, this is a binomial and another binomial. They have the same terms. The one is plus, the other one is minus. Right? So this is going to give us a difference of 2 squares when we multiply it off. Okay, x to the 6. Remember that x cubed times x cubed is x to the 6, right? Because you add those terms together. That. Okay, there we go. There we have G and H. What I will do is I will just take pictures of these answers and post them on the question afterwards so that if you mess up somewhere and you're going too fast, you can just check. So what I did for this one is I did almost like a grouping thing because I noticed straight away, okay, there we're going to have a difference of 2 squares, right, with those middle two brackets. And then I checked, do I have some kind of pattern with the other two? 2x minus 3y, do we see there that 2x, if I square that, I'm going to get 4x squared. If I square negative 3y, I'm going to get positive 9y squared. If I multiply these two together, I'm going to get negative 6xy. There I have a positive 6xy. Right? So if I put these two next to each other and I multiply them together, there we go. That will be a difference of 2. Okay. And there we go. That will be the difference of 2 squares. And then from there, there's no pattern here. Right. Is this going to give us a difference of 2 squares? Those two binomials or multiply? No, we don't have the same term, right? You don't want to. So all that you could do in that case was to FOIL them out. And then when we actually did that, none of those terms were like terms. All right, so that was the final one. Any questions on this exercise, guys? All right, exercise 1.2, you had to do all of number 2, right? Which is 2A to E, I think. Okay, there we go. This is now the one where we had some brackets cubed. So remember, we did brackets cubed. in school on Tuesday. So hopefully you were able to then apply that to this homework. So again, from the first two brackets, that is going to give us a difference of 2 cubes. Right, that one squared is that one squared is that one. The product with a different sign is the middle term. So these two brackets together and multiply them will give me those two terms.
Like that. On the first bracket, first one.
Cube. Yes. Yes. Well, yeah, so it depends. So you're going to cube that whole term. Cube a negative number, it's negative. Right. Yeah, I mean, things sort of gone over pear shaped, so just let me know. Because it was quite, yeah, there was a lot of algebra going on. Yes, that is a common mistake, guys. When you're asked to simplify, to multiply out, don't factorize as well, okay? You feel a bit embarrassed now, but you don't have to. Lots of people do it, okay? And people also ask, you have to do that. That's the only factorize the question says factorize. Or when we do algebraic fractions like these ones, the ones that we spoke about yesterday. Okay, we're still going to get to algebraic fractions. Yes, I will now. Then what I also wanted to say was, yeah, when you are multiplying out, you are supposed to end up with separate fractions, separate terms. When you're multiplying out, you're supposed to end up with separate terms. When you are factorizing, you're supposed to end up with one term. All right, so here you have 3 terms, that's perfect. So you don't need to try and make it simpler by factorizing. That's actually going the other way around. Okay. For B, this one was a cube, right? So that shortcut that we did the other day, you say the first term cubed. So that's going to give you 8x cubed. Then you do first term squared, which is 4x squared, times the second term, which is negative 4x squared, and then you times that by 3. Oh, must it be a minus? That's what I wrong. Oh dear, yes. Okay. So it's fine. It's not the end of the world. It's just that one thing. This would then just be a minus. But then this one must be a positive, yes. And a plus, and a plus. And then that one stays minus. Okay. And then the rest. This one was again a difference of 2 cubes. But guys, remember we're minusing the difference of 2 cubes, so we have to minus the whole difference of 2 cubes, right? Both of those terms. So it's minus 8x cubed minus 1. And now let me just double check. 8x cubed minus 8x cubed is 0, so those x cubed terms fall away. You have negative 12x squared, then you have plus 6x, and you have negative 1 minus 1, which is negative. Okay, sorry about that. Mistake number 1, we can count them up and see my score at the end of it. Okay, there we have C. So in C, I noticed that the first 2 brackets will give me a difference of 2 squares. Then the last one is again a cubed, and it looks like I did this one correctly because there we have a minus and a plus. So we just go over that cubed pattern again quickly. You do the first term cubed, right? So 3x cubed will be 27x cubed. Then you do the first one squared, so that's going to be 9x squared times negative 1, that's negative 9x squared. Then you times that by 3. That's negative 27x squared, okay? Then for the next term, you do the last term squared, which is going to be 1, times the first one, which is 3x, times 3 again, so that's where the plus 9x comes from. And then for the last term, you do the last term cubed. Okay. And then you must collect like this. We'll get one slightly in the I don't think so. No, you could get something like this with a square. Absolutely, that would be more common. Yeah. So just like a squaring binomial. They don't really test the binomials cubed in full that much. It might be like the difficult question, but no, it won't be as common as AP. Yeah. Please. All right, D. Yeah, so D was a bracket to the power of 4, which is all of that, right? Oh no. You could. So this is done. The whole bracket to the power of 4. Now guys, I'm going to put on a video for you guys just now, which is going to explain how we can use Pascal's triangle to actually get this answer. Don't worry, it's not another Pascal thing, because I'm still going to look at. Not really in the syllabus, it's just interesting to know. So I'll put that on people now. Basically, x plus y to the power 4. So I didn't use the shortcut of Pascal's triangle thing because you didn't know about it. So I wanted to show you how you would do that if you did it. So obviously you could just write it as the two brackets, or the same bracket squared and then squared again, right? That would be x plus y to the power 4. Then I did my shortcut for the binomial, shortcut for squaring a binomial. I did that twice. And then I multiplied them all out, right? But because it's 3 and 3, you're going to get 9 terms altogether, which you must then simplify from there, and you actually end up with those 5. All right, so x plus y to the power of 4 is actually equal to this. You just want to check that. So this looks very unsettling. I'm not going to lie. So it doesn't even fit into one line. Yes, but it's actually that. Yes.
You take the photos as So is there a simple way of doing it?
Yes.
There's a final answer.
It is. I'm going to show you the simple way now. You just want to see the answer. All right, guys. Did anyone get that answer for D? Oh, nice. Well done. Thank you. Saying well done to myself as well, by the way. Okay, that is simple. Yeah, it's just a lot of work. And guys, always the danger with a question like this is that, you know, if you make one sign error or one multiplication error, it throws everything else. But like I've said before, we see A. Okay, we mark with your mistake. So if you make one mistake, you will probably only lose 1 mark. Okay, everything else after that is correct. Unless that one mistake that you make makes the whole question much easier. Okay, then we don't just give you all the other marks automatically. All right, unfortunately, yes.
With the time, I seem to keep things in brackets for longer than they make sense. And that messes it up. Like with the square bracket.
Yeah.
Once we've done a shortcut, then I have to keep it in brackets.
For this first one, yeah.
Yeah.
No, you don't have to because there's nothing in front. But if there was like a 3 in front, you would have had to.
Okay, so if there's nothing in front, so I can take it out of bracket.
Yeah, but then when it gets to this, there's a minus.
That I just need to keep it in bracket all the time, and I end up multiplying it back up.
Okay, let's focus, please. Yes. No, unless it makes you make a mistake afterwards. But then your final answer also just must be different. Okay, the last one, what is happening here? So this was going to give you this is going to give you a difference of 2 squares, right? Those 2 brackets will give you that. Plus this was a binomial squared. Wait. Oh no, I left out a term. You see that I'm missing my y to the 6 here. Am I? Okay, let's just double check here. This, yeah, because I left out something there. So this would give us this. Yes?
Yeah.
Then when I did my binomial squared, I just did the first and the second term, and then I have no last term. Do you see that? So I am missing a plus y to the power of 6. Yes? Yes?
Well done.
And then minus 2, and then here, now guys, this is another case where because there's a minus 2, and even if it was a plus 2 or just a minus, Because there's something in front of this bracket cube, you have to do the bracket cube and brackets again. All right, so this then, this is that. Okay, then let's just see what my mistake has now caused. So this minus y to the 6 and that plus y to the 6 will actually cancel each other out. Let me just check it from here. Plus 2. Okay, so in this line, guys, I just added those two together. Right? Are we fine with that? X to the 6 plus x to the 6 is 2x to the 6. You didn't have to do that. I just kind of try and make my writing a little bit less. So if I see something that's quite obvious that I can add together, then I do that. Okay, so those two together will give us that. But then this minus y to the 6 actually can go away, right? Because there was supposed to be another plus y to the 6 that would have canceled it off. Right? So this minus y to the 6 and that one will cancel out. I'm actually just going to do that. Okay. There's a contiguous gap there, but you know what happened. All right, now we have, so basically that and that is that and that is 0. Then we have that term. Then I multiplied my negative 2 in, all right, into that bracket, and I got these 4 terms. Then 2x cubed y cubed, 2x to the 6 minus 2x to the 6 is 0, right? Yeah. 2x cubed y cubed, negative 6x to the 4y squared. There's no other term like that, so that goes in the final answer. This term also is the only term of its kind. That goes in the final answer. And now, this should just be negative 2 y to the 6. Is that better? So what's my score? 2 out of 1,000,000. That I could have scored, eh?
Better than I. Better than I.
Okay. I'm just going to keep that up for 1 second. I'm just going to find this video quickly. I actually hope now that this is the one. Oh, so you are the first. Oh, actually, yeah, we need.
Yeah.
Yeah. I can't do it. Okay, now I just need to check because I'm just used to work on MP3, but then it didn't work on it. Oh gosh. Okay, I'm just quickly checking here. Okay, let's check. Yeah, I know. I'm just checking if there's any sound. No. Okay. Let's try. Let's try. No, okay. Who knows? I'm not sure. There is no other plug here. What is that? The mouse? What about actual rock? Okay, guys, what I'm going to do is, yeah, let's put a pause, a pin in this thing, I suppose. I do really want to play this for you guys, but I'll just get Mr. Butler in to just check this thing because you won't be able to hear. Let me just check. Maybe just put a heading on the next page, Pascal's triangle, and then we can do a little note on Monday when we've watched the video. But then we'll just move on to factorizing for now. Like Pascal, like your name.
I don't spell anything. There's a reason I take science subject. I can't spell. I can't spell anything. I still have.
Okay, there we go. Pascal's triangle.
I got the board. Thank you.
All right, let's calm down. For binomial expansion. Okay, and one page will be enough space. So just leave that page open and then we will come back to this on Monday. Thank you. All right, guys, we're going to be doing some factorizing now. You have been working on factorizing in 4 already. Okay, so I want you please to open your AP textbooks on page 3. So yes, I do. That's actually important. Thank you for reminding me. I'll give you this one just now. Mrs. Court has given me stickers. All right. So I'm going to come around now. Do you guys all have your AP textbooks here?
I don't have mine. I only have the first.
Yes, yeah, you're supposed to only have to bring the first one, that's fine. So I have these stickers, I'll show you guys now, because textbooks keep going missing basically, because we don't have them barcoded. So you can't really see, but it's like a thin sticker. So I'm going to write 1A, 2A, 3A, 4A so book A is book 1, all right? They are supposed to be, I think, there are currently 32 books in this class, and then Sam, yours is 33. But she has already numbered 1 as 33, so your book must come from her. Okay, so I just remember to get that. So that if one of the books go missing, we know, okay, we have all the books from 1 to, I think there's 60 altogether, but 52 is gone. Okay, we've got 52, and then we know that it's you. Okay, so we'll do that admin stuff now. For the first bit, I want you guys to read through this revision of factorizing these examples. All right, if you want to, you can copy them into your workbooks. So you can write factorizing as a new heading. I already said that we will do that on Monday. Just leave the page. Yes.
And it's a single formula.
It's a triangle that gives you a formula for all different powers of the bracket. One page. Okay, you can just write factorizing. If you want to, you can copy down the examples that have been done here, all right? The highest common factor examples. The first one is quite simple. If you're looking at the second one here, there's a 4x squared minus y squared minus 2x squared minus y plus 8ay minus x squared. Are all 3 of these brackets the same? This one is different. We need to do a switch around on that one. Okay? Remember, when you do a switch around, you change the sign in front of the whole term. So this plus 8a becomes a minus 8a. And then you can switch around the stuff in the brackets, all right? Oh, they said you swap around. Okay, I may switch around. Anyway, it doesn't matter. Then you can take that off. Yes.
Something that makes the x squared minus y squared cube the bracket. Maybe not.
They're not multiplying the digits, taking one off. You're dividing by the bracket. Okay, so guys, you are more than welcome to write this down. All right. Next one, difference of squares we've done, which is like before. I almost feel like we maybe did this one, a similar one. We've got the bracket, and then you could go from there. All right. So you can write those ones down if you want. The one thing that I don't like about this one is that we have a bracket square in this bracket. You're actually not allowed to leave it like that, guys. All right, this bracket square you will have to multiply out, unfortunately. Okay, and how would we do that? By using this is a bracket square. So the square in binomial shortcut we would use. Okay, so I'm just going to make a note here. Multiply.
You just want us to work through the
You can either just read through them, make sure that you understand all of them, or you can copy them into your books as examples. Then there are some trinomials. Guys, B and C are interesting trinomials. Let's just all quickly look at B. X to the 4 minus 5x squared plus 4. Have you seen a trinomial like this before? With an x to the 4. Yeah, maybe you've heard an example or two last year, right? Let's just pretend that this was just an x squared and an x and a minus 4, right? So you can try that trinomial. This was just x squared minus 5x plus 4. Do the 4. Factor the 4, the sum of those factors, right? It's going to be -4 and -1, right? Now look at what they did in these brackets. Instead of doing x minus 4 and x minus 1, which is what we would have gotten if we factorize this, we would have gotten x minus 4, x minus 1. They have x squared minus 4 and x squared minus 1. Guys, remember when you are factorizing the trinomial, the product of your first terms in the two brackets must give you the first term of the trinomial, right? And the x squared times x squared will give you x to the 4. -4 times -1 will give you +4. Then when you do your outer and your inner, outer there and inner, it should give you the middle term. So x squared times -1, that's -x squared. And when you do this, -4 times x squared is -4x squared. What's -x squared minus 4x squared? -5x squared. All right, so be on the lookout for that, guys. You can get something like this. Even in 4, actually, they can give you a question like this. Where it's x to the 4 as your first term, x squared as your middle term, and then again a constant. All right, it's a special type of trinomial. What's happening here? Next one, in C. We have a bracket for you. -2 times that same bracket to the power of 1, right? And then a constant term. That's also a special type of trinomial, right? They are introducing a method of solving complicated equations in this example. We call it the K method. Where if you are noticing that there's the same bracket that's being repeated multiple times, you can actually introduce another variable, usually K, but it can be anything, all right? You can introduce a different variable and substitute it, use it in that bracket space. So here, do we see that these two brackets are the same? Right? So if you say that K is going to be equal to that bracket, then it simplifies the actual trinomial that you have to factorize. So then your bracket squared becomes K squared, -2 times the bracket becomes -2K, and then you have -3. Now we can see that this is a simple trinomial, right? This is an easy trinomial to factorize. We're going to look for factors of 3, but then the difference between those factors must be -2. So that's going to be 3 and 1, right? +1 and -3. There we have K plus 1, K minus 3. But now, guys, this is not equal to that factorized. So now what you've actually factorized, you need to now, in the place of k, again, go and put what k was actually equal to. Right? We said that k is x squared minus 2x. Do you see now in the next line, k minus 3 is that bracket minus 3. And k plus 1 is that bracket plus 1. But now, guys, what do we have in each of these square brackets? Really? What's the same way as bracket? That's my Romeo. That's my Romeo. So x minus 3 minus 3 will give us those two brackets from the back side. It's probably not factorized binomial, but you can always take the brackets and factorize further. All right? So if you factorize these three terms, this trinomial, it will give you those two brackets. Ooh. Just underline that. Here we go. That will give you those two brackets. And if you factorize this trinomial, that will give you that, which is the same as x minus 1, which is also correct. Okay, so this is a typical BCAP factorizing. Right. Yes. About? B, okay, yes. Oh, example 7. So you have to do a switch around in that last.
I guess that.
So then, oh, I see, they've taken out not only the bracket, but also 2 from each of them. There was a 2 that was also common in all three terms. You see, that's where that 2 in the front is coming from. So you have 4 and 2 and 8. So you can actually take a 2 out of all three of them as well. So then each of those three terms needs to be divided by 2 and that bracket. Okay. So there's 4 and 2 and 8. You can take out a 2 and the bracket, and then you must divide each of them, and then mark out. Please.
So I'm looking up for example now I just know it. Do you now have to actually square the bracket? Square.
Yeah, because if you now work that out, then you're going the opposite way and you're going to multiply out. See, then you're going to get, you're supposed to have it like in simplest bracket. Okay, because if you multiply it out, you're going to get that in C, so you'll be working it out. Okay, guys, so I do suggest that you copy down at least B and C from example 9, right? But I'm going to give you the rest of this lesson now. To work through these examples, if we're just looking at the next page, and Sam, I'm going to give you my book to do that.
Okay.
Page 3. On the next page, let's just quickly look at these. Sum or difference of cubes. Right? We've worked with when you multiply, you get the sum or difference of cubes. But now we also need to be able to factorizing in full and while, guys. Right? So here, if they are giving you x cubed minus 8, you need to recognize, just like you recognize that x squared minus 4 is a difference of 2 squares, you now need to be able to recognize this as a difference of 2 cubes. All right, so again, we're going to put 2 terms, but remember we can now have a sum or difference. Okay, it doesn't matter. For the cube, you can have a plus or minus in between it, and they need to have cube roots. So x cubed has a cube root and 8 has a cube root. Am I right? Okay, now you're going to set up 2 brackets. That's the way that I do it, is I always set up my binomial first. And what are you going to get in the binomial? Very easy. The cube roots of each of those terms and the same sign. What's the cube root of x cubed? X. The cube root of negative 8 is? Negative 2. That is what goes in the binomial. Then I always use my binomial to set up the trinomial. Okay? So you're going to do the first term squared is going to give you the first term there. The last term squared is going to give you that last term. And then for your middle term, you multiply the 2 terms together, which is negative 2x, and you change the sign. Okay, and then you're done. That's factorizing. So guys, what happens with these questions or these differences, or some of difference of cubes, is that you will always get a trinomial that actually can't be factorized in the last bracket. Okay, so we can discuss that in more detail on Monday if you guys want. But you can check this trinomial here. You can just ask yourself, can I have factors of 4 that when I add them together will give me 2? Factors of 4, when I add them, will give me 2. Okay, the factors of 4 are 4 and 1 and 2 and 2. 4 plus 1 is 5. 2 plus 2 is 4. So this one actually can't be factorized. Okay, and that's what always happens, but we can just check. Let's quickly look at the next one. 27 plus x to the 6. Does 27 have a cube root? Yes. Does x to the 6 have a cube root? Yes. So we're going to set up our binomial first. The square root of 27 is 3. The square root of positive x to the 6 is positive x squared. Close bracket. When you use your binomial to set up your trinomial, 3 squared is 9. X squared squared is x to the 4. 3 times x squared is 3x squared. And then you change the sign to minus 3x. And that's it. Okay? So guys, we did summarize this. We have notes now. We did summarize the actual multiplying out. Right? We did this summary in your books already. We're just going backwards. We're now going from this question to this as an answer. Right? So you can always look back at this note if you want to. But we're also going to practice it in 4 again and. Right. We're looking at this one. This is a bit more difficult to notice that it is a difference of cubes, I suppose. But x to the 9, I think we can that will have a cube root, right? And 512, you might not know, but the cube root of 512 is 8. And guys, if you're not sure, you can just check. Okay, just type into the calculator, cube root of 512. So the cube root of x to the 9 is x to the 3. The cube root of positive 512 is positive 8. Then we're going to square that one, which is x to the 6. Square that one, which is 64. Multiply them together, that's 8x cubed minus the minus 8x cubed. They left out a bracket there. Now when you've done that, this trinomial can't be factorized, but this again is a sum of 2 cubes, right? So that you can factorize again. So that's something to look out for, guys. Whether you can actually factorize the first term again, binomial. Okay, this one, C, is a bit tricky because now we're working with a bracket cube, but the same method applies. The square root of the cube root of a bracket cube is just a bracket. The cube root of -1 is -1. Then we square in each of them, right? This bracket squared. That -1 squared. You multiply them together and you change the sign. And then you're just going to have to simplify those brackets separately. Okay, because now you have brackets within the brackets. So you can do that. And in the end, guys, let's check this trinomial. Factorize it. Factors of 3, and when I add it together, this gives me -3. 3 is a prime, right? So the only factors are 3 and 1. If I have 3 and 1, there's no way that I can add those numbers together, even if it's -3 and -1. That won't give me -3. It will give me -4. So this one can't be factored. Okay, guys, so you are going to do some note making out of these examples. You can copy down the ones that you feel you need to, all right? Or you can copy down all of them if you want. I know that many of you are going to be on a camp this weekend, so I'm not going to give you homework specifically, but I do want you, if you have time this weekend, to look at, let me just check. Yeah, we haven't done that as factorizing, we've done it as multiplying out, so all of it. Hold on. I would like you to do, if you have time this weekend, guys, I would like you to do number 3. No, not the whole one. Let's just say, oh my goodness. Finishing here. 3A, 3B, 3C. If you get time, you can practice those three. They are some differences of cubes. Okay, so it would be a good idea to try and find some time just to practice those three. Okay, so exercise 1.3, page 4. 3, A, B, and C. Yeah. I don't understand why in the double code. Why you that's why -1 to get bracket. So that is your binomial bracket. So you take the cube root of each of the original two terms. The cube root of -1 is -1. Yeah, because so how many terms are you starting out with in the question? 2. So the cube root of the bracket cube is just the bracket. So that's the first term of the binomial. And then the cube root of -1 is -1. So that's the second term of that binomial. So all trying to you look at those things, all trying to happen to you. So they're all trying to move, but they actually not factorize. Not necessarily, you would have to look at the actual numbers. So if this was a 4, then if this was going to be a factor of -4, because then you could have said -2 and -2. But just because it's a -2, then can't actually take the factor of 4. Okay. Yes.